Okay, welcome to a quick lesson on the concept of the sketch view or section view. What we are talking about is the type of view that is used to describe the inside of a particular part or drawing. Could be structural, could be mechanical, could be all kinds of things which section views are used for. Now, to begin with, let's just talk about simplicity, okay? Concept of the section view is tricky primarily in the area of visualization. The most problem that individuals have with understanding what a section view is and what its purpose is just visualizing what they're looking at. So we're going to start through a couple basic steps, and you can just kind of follow along, see if you get the hang of it. I'll give you a couple little examples to try out, see if you understand, and we'll see how you do. So first off, let's start off with a good old-fashioned apple. Actually, let's not start off so close to the title there. Here we go. Here's the apple. It's a very misshapen apple. Seen some rough years. Alright, there's a little stem and the leaf, etc. So there's the apple. Okay? Now, when I actually take this apple and take a knife, okay? Here we go, my nice Ginsu blade right here. There it is. I'm going to take this knife and I'm going to use it to slice the apple. So I'm going to take it, and this blue line here will represent the slice. Let's say I cut it right down the middle, right through here. And my knife goes and it slices and it cuts my apple in half. Okay? So from there, the next step is the apple becomes two parts, correct? We'll say we tear off the stem and the little leaf too. So anyway, my apple now has two parts to it. And we'll say this is the right side of it, and this is the left side of it. So what you see there is the right side, and here is the left side. Now typically, actually I better not do that, that confusing. We have pulled the apples apart from each other, okay? There you go. Now of course an apple has a couple of things in it, little seeds and stuff. So there's the apple separated from each other. Here's the outside red of the apple, and in here is the white part of the apple. Okay? So our first step was to cut the object. The second step was to separate them. Then we move on to the third step. The third step is to get rid of one half of our section, the other half, the part we're not going to look at. So let's say we're going to get rid of the left side and we're going to keep the right side. Okay, so that means left side right here, it goes away, big X through it, and that leaves us with only the right half of our cut. There's my little seeds in the apples. This is the red area, of course. Actually, again, better not show that. That'll be confusing. There's that part. And then we are given this half. Alright. Now we decide we want to take a look at this half, looking at it straight on. So we have cut it, we have pulled it apart, and we've decided which side we're going to keep, and now we're going to turn it at like so, or some kind of direction, so that we can look at it in a primary orthographic way. So let's go down to this point here, get ourselves more space. Here we go. We turn it and we look at the apple straight on. And we are primarily focused on looking at the apple in the same, at the surface I should say, that we cut. So right now I am looking at the surface that we cut, and there's my two seeds. Now you'll notice I don't see the outside skin of the apple anymore. All this is white for the inside fruit of the apple. So this is a section view of the apple. So here's the section view of the apple. Now the last thing that we do with the section view is we hatch. Key word here, hatch. We hatch the surface that was cut. Basically, where the blade touched, if there's material there, we hatch it. And this is what a hatch is. I'm going to change color real quick just to make it distinguish. So it lets the viewer know, hey, the surface you're looking at is the surface that was cut by the blade. And this is a section view. This is all there is to it. You cut an object. We'll just kind of recap real quickly. You cut an object right here. Then you split it apart. You get rid of the half you don't need and keep the half you do. And then you turn the half. Here's the turning process. You turn the half and hatch it. So you get the half that you want to look at its surface that was cut, and hatch the surface that was cut. That is the overall procedure with a standard hatch. Let's do another example in a more mechanical format. Okay? So we'll start off with a good old-fashioned block with a hole in it. And this hole goes all the way through the part. So step one would be to cut the object. So I'm going to cut it. Well, let's change color real quick. We'll cut the object right down the center this way. So there's the cutting point. There it is, and cut it. So there's step one. Then we move on to step two. We separate the object. Of course, all this is happening in our mind. It's not actually happening on paper. I'm just drawing it out for you. We separate the two surfaces, or two parts of the object. There they are, they're separated. There's that one, that surface goes back in. And we'll go ahead, just for understanding purposes, I'll go ahead and hatch the surface that was touched by the cutting blade. So there it is. And there it is. Now you may ask yourself, why didn't I actually hatch inside the hole in here? Why didn't I hatch that in? Well, the answer, of course, is because the blade never touched it. The blade came up and down this way. It never came inside here. It only went this way. So that's why we didn't hatch the inside of the hole. So anyway, there's step two. Moving on to step three now. We get rid of one side or the other, and let's say we're going to keep the right side again. So we keep the right side, we throw away the left side, which means we are left over now with this part of it. And of course, I'll hatch in the section that was touched by the blade. The Super Ginsu Katana blade. And then our last step is to, or kind of final couple steps, is to turn the object such that we are looking head on with the surface that was cut. So here we go. And there we are. This is our section view. And that's the principal concept right there. Cut, remove, get rid of, turn, and hatch in. You can see, of course, here's our hatch. And of course the red represents the outside surfaces of the object, and we are looking right at these surfaces as they are done. So for example, this right here is surface 1, this is surface 2, this is surface 3, here's surface 3, here's surface 2, and here's surface 1. That really is the simplest way to consider how a hatching works. And that's the major procedure. No matter how complex the object is, that's what you're doing with a hatch. You're just cutting, pulling apart, getting rid of a half, and looking at what you have left in its most basic sense. Now, what is, I'll move that there. In looking at this overall object, how can I tell that this surface is a hole? Well, the fact is, when dealing with hatches, you go ahead and throw in center lines when dealing with cylindrical surfaces. Only when you actually see it. Now you'll notice that even if I were to add a hole into this part, for example behind the hatch cut, like back in here or something, let's say I add a hole up there, and they pass through the object, notice that they do not show up here. See that? I don't put them in here. Hatch drawings are only concerned, or section view drawings are only concerned with the surface that is cut. We don't worry about things in front of or behind the cutting plane. Okay? But where cylinders were shown, I mean, this is a surface that was available to us. We just don't actually hatch it because it wasn't touched, but we can still see it in the section view. We still use center lines there. Also, no hidden lines. See that? There's no hidden lines. There's no objects behind, and there's basically a section view is a very isolated type of drawing. You don't show a lot of information on the part's features that are not within that cutting plane. So that's something very, very important to remember, is that your only focus and interest is in the area that is touched by the blade. Okay? Well, let's try a little something else. Let's try a little exercise together. It doesn't really matter how you're actually drawing these. If you're using a CAD system or if you're drawing them by hand, that's irrelevant. The techniques and the logic behind it is all the same no matter what. So however you are actually drawing these things is up to you. CAD systems do a better job, obviously, in terms of final production, but just for what we're doing now, sketching works just fine. Let's take an example. Let's say that I give you a part that looks like this, and it has a hole going down through it, and it has a couple holes back here. Alright? And just for fun, it has a hole right here. All these holes go all the way through the part, and let's say I ask you to draw for me the section view that passes through right here. Here's the cutting plane. This is cutting plane number 1. Passes all the way through the part, and I want to keep, and this is the right side and this is the left side, I want to keep the right side of the part and look at its section view from this cut. Why don't you pause the video and go ahead and draw that for me, or sketch it, whatever you want to do, or just visualize it in your mind, doesn't matter. Just give me the actual representation of what that part would look like. Okay? Go ahead and do that now. Okay, section 1, this particular part would look like this. Here's the outside boundary of the part. This is the hole coming down through it. This is the center line to represent the fact that it's a cylindrical hole, and then I'll hatch in the portion of material of the surface that was cut by the blade. Now, there's all kinds of rules and spacing and stuff like this and angles associated with the hatch pattern. That's not what we're talking about right now. But to understand, there are specifics for this kind of thing. But anyway, this is section view 1. So let's say if this block was 3 this way and 2 units tall, then my 2 would be here, and my 3 would be here. Just for your personal orientation. Now we're not worried about dimensioning this section view, we're just talking about showing that for your reference. Okay? Now let's try it again. Let's say that I ask you to do a section view through the part through right here. There we go. And this will be section view 2. Go ahead, pause the video, and try to draw section view 2 for me. Okay. Well, section view 2 will look something like this. It'll still have the same overall dimensions, being 2 this way and then 3 this way. And I'll have the 2 small holes, or at least half the holes in terms of the section view, there. I will hatch in where material was cut and where material was back set, so, or where it wasn't cut will not be hatched in. And of course I'll add in the center lines to represent the fact that they're cylinders. This is section view 2. Alright, well hopefully you got that right. Let's talk about it a little bit. Again, remember that just because I draw in a center line, you only do that when dealing with cylindrical holes. If it's a square hole or slot or something like that, it's not cylindrical, you don't throw that in. It would be blank. Remember that. Let's try again. Let's say that I give you one more and I say, here is the cut for section view 3. Go ahead and pause the video and create the section view for me. Okay. The result for section view 3 again will be 2 units this way, 3 units this way, 2 units this way, 3 units this way. And the hole goes this way. Just like in one of the earlier examples. There's my center line, and there is my hatch. It's pretty easy to work with. Now you'll notice, again, I do not have any hidden lines showing. This is section view 3. Oops, if I the right view there. View 3. There are no hidden lines. Even though there's holes back there, like right back in there, and it's behind our section view 3, we don't show them. So don't forget that. And again, if this hole had been a square, or had been some kind of rectangular notch, we would have gotten rid of the center line. But since it's not, we don't have to worry about that. Alright, so those are the examples of section views for the problem that I just gave you. And hopefully you can kind of see where we're going with this and get a feel for this. Just remember, slice it, pull it apart, get rid of the half you don't need, and then hatch in, or turn it towards you and hatch in what was touched by the blade. That's the easiest way to kind of remember this. And so there's that group. Alright, so that's the overall concept of what we're doing. Let's talk about, well, half this page for us here. Let's talk about doing it in a more drafting compliant way. Because typically you don't get to have these nice isometric views of parts to hatch for, or section view from. You're not given things like this to work with. In fact, you're typically given something like this, where this is the top view, this is the front view, and the right side view looks something like this. Give or take some hidden lines, of course. That's what you're typically given. And you don't have this thing, this nice isometric to work with. So we have to represent the same information to the viewer, or interpret the same information from what we're given. So to represent the cutting blade with an object, we do something like this. It's an arrow with a phantom line attached to it, typically is what is used. Looks like that. And typically they'll have letters associated with it too. Alright, this is a section line. That's what that is. It is used to represent the blade itself and where it cuts. So for example, if I wanted to slice this object right down through here, which would be the equivalent of slicing it down that way too, instead of actually drawing it with just these random little lines like I've just done, put that back in, I will go ahead and draw a section line like this. Phantom, come off, arrow that way, letter, letter. That represents taking the knife and slicing down the object, the equivalent there in the front view or right through here in the top view. However, it's shown in a more orthographically acceptable manner. Now you'll notice these arrows and the letter. The arrow represents your eyeball, what you're going to be looking at in this section view. So what it means is, where the arrow's pointing, means that you will get rid of the half that's not in the direction of the arrow. So for example, I'm going to get rid of this half of the part, whereas I'm going to keep this half of the part. Give a little check mark there. That's what I'm going to keep. This is what I'm going to throw away once this object's cut. The equivalent thereof down this view is I will keep this half, I will throw away this half. Okay? So, the resulting section view from this particular part looks like this. Section A-A, which relates to the letters used in the section line. You see there? And of course the hatching, because it's solid material. Okay. And just to make sure everyone understands where we are, if this value for this length is 2, then this value would be 2. And if this value is 4, then from this particular section view, this value is 4. See that? That's what we're looking at. And that just helps you get an orientation of what you're seeing. Let me trim some of that back off. Okay. Can't go back any further, so I'll just erase that one. Alright, so this is section AA. Okay. Now let's try another one. Let's say that I do a section through here. Make it nice and tricky. There's my section line, or what is representing my Super Ginsu knife. Now here's a question for you. With this in mind, which half am I getting rid of? Half, we'll call this half X, and this is half Y. Am I getting rid of X or Y in this particular case? Correct answer is I'm getting rid of X, because it's on the back, it's not in the direction of the arrows pointing, it's on the back side of the arrow, so the back side of the plane. So that's what I'm getting rid of. I'm keeping Y. So let's draw it out for ourselves. This particular section would look something like this. It would mimic a good portion of what the top view looks like since we're in the front view making the cut. And there is the cut material. Now, some designers or some rules will just allow you to just do this, B-B. You don't actually have to write out the word section. It's kind of obvious. Sometimes they'll also include the scale in case you perhaps change the scale from one drawing to the other. But there it is. That is section BB. It looks very similar in shape to the top view because the section line was done in the front view. See that? Let's try another one. And you can always pause the video as I'm doing these and kind of try it yourself and make sure you kind of get the hang of it. Let's take one that is, let's go this way. There is section CC, and the result for CC, if you want to do it before I do it, go ahead and pause the video. But section CC will look kind of like this. Actually, a little bit thicker than that. There we go. That's what section CC is going to look like. Notice that only the portion that is cut by the plane is hatched. This portion is beyond the plane because it's this surface right here. It's beyond the plane, so therefore it doesn't get hatched. Kind of keep that in mind. Things that are not included in the cutting plane or not touched by the cutting plane, you may see them, but they don't get hatched. All right? I'll make a little box around that one just for our organization of this drawing sheet. And we'll move over here a little bit. Let's take another part. Let's go with a part that looks sort of like a part drawing that looks sort of like this. Here's the top view. Here's the front view. And here's the right side view. There we go, with the addition of some hidden lines there. Okay, then I take my section plane and I decide to section right through here. That's supposed to be a phantom line, sorry. Section AA. And section AA will look like what? If you want to try to beat me, go ahead and pause the video and give it a shot. See what you do. Alright, section AA will look like this. There's the whole representation that only portions of this surface were sectioned or cut. And there we go. This is A-A, and we'll say the scale is 1:1. And that's it. Now let's try a little bit more complex. Let's go a section view that goes like this. Again, it's supposed to be a phantom line right there. Sorry for not being real good in quality. There's BB. That section view would look something like this. Odd that we're kind of traveling up this time, isn't it? How about that? Did you get that one? That was a little trickier. It's from that view. Now, what if I were to ask you to create a section view that was like this? CC. What would you tell me if I asked you to create section CC? Well, hopefully you would tell me, hey, that's just the exact same thing as section BB. So it's the same thing as doing that, and you don't have to do it. And I would say, you're right. That is correct. Well, what if I were to tell you that I want a section view right here? That I want this to be section DD. Again, you should probably tell me that, hey, that's the exact same section as section AA, and it doesn't need to be repeated. And I would be, okay, you're right. Well, what if I turned around and asked you to do section EE? What would you tell me? Well, hopefully you would say, well, that's a new section because that's the only one that's being done heading in this direction. So therefore, we don't already have it done, and we'd have to draw it. And that we would. Now, since the part's pretty much symmetrical, it would pretty much look like section AA just reversed or mirror imaged. So there's a good little point to kind of think about in your two different views, or your several different views, and how one section view will mimic another section view from a different orthographic projection, or based off a different orthographic projection. Now, as the drafter, or as the person who's looking at a blueprint, this is what you have to interpret. You have to interpret what material is hatched, what material is not hatched, what material is real or is actually supposed to be hatched and what is not, and basically what's going on the inside. So you have to interpret what you're seeing based on these section views and the actual lines that go with them. It's your job to kind of figure that out. And practice makes perfect. Fact is, if you don't practice this a lot and kind of play around with it, you'll not have a very good visualization ability. It's not about necessarily having natural talent, it's just about practicing till it kind of sinks in. Okay? Well, that's all we'll do for this little quick lesson. A little beginner's approach to section viewing. There's a lot more to it, and there's a lot more details that you can have covered elsewhere. This is a little bit to get you started. So, good luck with this, and we'll see you later.